In this video, we're going to talk about relations and implicitly defined functions. Now, there are many useful curves in mathematics that fail the vertical line test and therefore aren't functions. One such curve is a circle. While y is not related to x as a function in this instance, there is certainly some sort of relationship going on. In fact, not only does the shape of the graph show a significant geometric relationship among the points, but the ordered pairs x, y exhibit a significant algebraic relationship as well. They consist exactly of the solutions to the equation x squared plus y squared equals 4. Now we'll get more into circles in chapter 8. Now the general term for a set of ordered pairs x, y is a relation. If the relation happens to relate a single value of y to each value of x, then the relation is also a function and its graph will pass the vertical line test. In the case of the circle with equation x squared plus y squared equals 4, both 0, 2 and 0, negative 2 are in the relation. So y is not a function of x. Let's move on to example 6 to put it to numbers. Now one thing I do need to change. I do need to change the first ordered pair here. This should be the point 2, negative 5. Now, which of the ordered pairs, 2, negative 5, 1, 3, and 2, 1 are in the relation defined by x squared y plus y squared equals 5? Is the relation a function? Well, first point is 2, negative 5. Let's check that. So we'll have 2 squared times negative 5 plus negative 5 squared. Well, 2 squared is 4 times negative 5 is negative 20 plus 25 equals 5. So 2, negative 5 is in the relation. Now, if we have to check 1, 3, that would be 1 squared times 3 plus 3 squared. 1 squared is 1 times 3 is 3 plus 9 equals 12. This does not equal 5. So 1, 3 is not in the relation. Now, if we have to check 2, 1, we'll have 2 squared times 1 plus 2 squared. Which means instead of 2 squared there, we're going to actually have a 1 squared. So we'll end up with having 4 plus 1, which equals 5. So 2, 1 is in the relation. Now, is this relation a function? Well, according to the definition, in order to be a function, if it relates a single value of y to each value of x. Well, since 2, negative 5 and 2, 1 are both in the relation, this is not a function because there are 2 values of y for 1 value of x. So there we have it. So the first relation is not a function. A nice easy way to tell is if you have a y squared, that will tell you it's not a function also. Now moving on to B, it says which of the ordered pairs, 1, 1, 4, negative 2, and 3, negative 1 are in the relation. So is the relation a function? Well, let's check 1, 1 first. So that would be 3 times 1 plus 4 times 1. That would be 3 plus 4, which is 7. That does not equal 5. So 1, 1 is not in the relation. Now if we check 4, negative 2, 3 times 4 plus 4 times negative 2, that would be 12. Plus a negative 8, which is 4. That does not equal 5. So 4, negative 2 is not in the relation. Now if we check 3, negative 1, 3 times 3 plus 4 times -1, plus 9 minus 4, which is 5. So that just tells you that 3 -1 is in the relation. And also, 3x plus 4y equals 5 is a function. For each value of x, there is only one y. And if you did solve this for y, you'd understand that this is a line. Now let's revisit the circle that we had before. X squared plus y squared equals 4. While it is not a function itself, we can split it into two equations that do define functions. So what we can do, we can subtract x squared from both sides. Then take the square root. Remember, when you take the square root, we're going to have the positive and negative part of the square root. Now, the graphs of these two functions are respectively the upper and lower semicircles of the circle we just talked about. They're shown to the right, well, before. Since all the ordered pairs in either of these functions satisfy the equation x squared plus y squared equals 4, we say that the relation given by the equation defines the two functions implicitly. So here we go. Let's solve these. Now you might be able to figure out in number 7a that this left side is actually factorable. But x plus y times x plus y equals 1. That will simplify to x plus y quantity squared equals 1. Now to solve this, we're going to take the square root of both sides. Then we'll solve for y. So y will equal 1 minus x. Y will equal -1 minus x. So here are our two equations, two implicit equations. Moving on to B, it's going to look like a previous one, like x squared plus y squared equals 4. We're going to subtract x squared from both sides. Then we're going to take the square root. Again, in order to give us two equations, it will equal the positive square root of 25 minus x squared and the negative square root of 25 minus x squared. So there are your two functions solved implicitly. Now your job at the end of this video is to tell me the score of the Cleveland-Baltimore game as soon as you get into class. Put it on a piece of paper and place it on my desk with your name on it. Have a good night.